Okay, the purpose of this video is to help you prepare for a retake on all or part of your climate quiz. And so the climate quiz actually had two standards, standard 20 about the water cycle, and then standard 21 about wind patterns and ocean currents. So if you don't need to retake the water cycle standard, you can skip ahead to the next part if you need to. But let me tell you this about the retake. The retake is going to be the exact same quiz with one exception. I am going to actually be mixing up the matching, right? So you can't just memorize the alphabet, you've got to think. Okay, so question number 1, the troposphere is I, the layer of the atmosphere that clouds form in. Question 2, condensation is actually A, gas to a liquid that requires cooling. Question 3, evaporation is C, liquid to a gas requires heating. Transpiration, number 4, is F, evaporation from plant leaves. Precipitation, number 5, is answer B, falling water from clouds in the form of rain or snow. Number 6 is H, a spring is when groundwater actually meets an opening at the surface. Number 7, D, infiltration is when water soaks into the ground, infiltrates the ground. Number 8, runoff, is G, when water moves downhill with the force of gravity. And finally, an aquifer, this is kind of a weird one. It's not a water source. It's a rock that has the capability of storing water. So it has whole space in it that could possibly store water. Okay, now our next one. Our next one is a short answer, still on the same standard 20, and that is evaporation needed for clouds to form? The only right answer there is yes. Now, explain your choice. Evaporation puts water vapor in the air in the first place. Another way to say that is it provides the raw material for clouds to form. So without water vapor in the air, you have nothing to go to the final step of cloud formation. But does evaporation directly make clouds? The definite answer to that is 100% no. And that's because condensation directly makes clouds. So you have to have evaporation first to go from a liquid to a gas, then water vapor, that gas has to turn back to a liquid. And it doesn't rain down a gas, right? So that makes sense to us that clouds couldn't be a gas. Okay, now, next step. Let me show you this. Okay, so this is a diagram that really explains what I just talked about, that we have evaporation happening first, so water goes from a liquid to a gas. Then you notice cooling in the upper part of the troposphere that reverses the evaporation process and condenses the water back to a liquid and forms clouds. Okay, now that is the part that is on standard 20. So if you need to retake standard 21, then you need to be doing this. Okay, standard 21 is about wind patterns and ocean currents. So the right answers here go C, A, B. They will not be in that same order if you do the retake on this part. So the jet stream is known as the superhighway for storms in the upper troposphere. The westerlies, though, this is A, that's our global wind pattern in Ohio, but the global wind pattern in the tropics is called B. Those are the trade winds. Now, this shows it, right? So here we have the westerlies that go from the west to the east and the trade winds that go from the east to the west. Okay, so next up, our next question asked you to pick one of the properties of air demos from class and describe the demo in detail and sketch if you want, and then clearly state what property it showed. So I'm going to be showing you 3 of them, and you only have to pick one. So this was the demo where air takes up space. You can see that you had the speaker with a paper towel. I went straight down into the bin of water. The paper towel came out dry because air was taking up the space. So if you like that one, you can sketch that and explain that. Now, this is the one that showed air had mass. Remember, we had an inflated balloon and a deflated balloon, and this contraption acted like a balance. Air isn't nothing, it's something. And because air had mass, you could see it tilt down to that side. Now, my favorite is this one. Air exerts pressure. We know that there had to be high pressure here around the cups and lower pressure in the cups in order for the air to hold those cups on. Again, you get to pick your demo there that you want to draw and explain. Okay, so what might have been the most challenging part of this whole quiz was this diagram analysis, which really I probably should have called it a map analysis. So here you have 2 air masses. You have air mass 1, just like our play, like our puppet show with the Sun King and the Pressure Fairy, with 58-degree temperature. You have air mass 2 with 62-degree temperature. And my first question about this was which one had the lower pressure? And the right answer to which one had the lower pressure is air mass 2. Now, you might be like, well, how did I know that? And I'll show you this in a second typed. Well, that's slightly warmer air. So warm air rises higher, so the pressure on the surface is actually lower, okay? Now, how did I know? So here's what you should have. You should have air mass 2 has the lower air pressure. And I know this because, ready, the temperature is higher, so the molecules spread out, making it less dense, or you could say having a lower density. The less dense warm air rises, so it pushes on Earth with less force. Notice that I've underlined the 3 words that I'm scoring for that you must have in that response: temperature, density, and force. Okay, now still going with this map, what direction would the air come from? So notice what I've written in here, typed in here. Higher pressure for the colder sinking air, lower pressure for the warmer rising air. So how does the air move? Well, which air mass is more forceful? It's this one here. So you're going to have the air move from high to low pressure. So it would come from the northwest and go toward the southeast. So you should have for sure, oops, I messed up there just a minute. Okay, so you should have for sure number 7, northwest, is coming from the northwest to the southeast. And now let's explain our choice. Why is this scientifically accurate? It's scientifically accurate because, whoa, that's bad teaching. Better. Okay, so it's scientifically accurate because air moves from high to low pressure. Think of it this way: more forceful air always pushes away the less forceful air. Now, this one might have been tricky. What do you think about the wind speed in this situation? Well, you have to ask yourself, is this a big temperature difference? 62 to 58? Not really, right? Only 4 degrees. So that tells us that the wind speed would probably be pretty slow because of this reason. The temperature difference is small, so the pressure difference is small. So when you have a big temperature difference, you get a big pressure difference, and that means that the high pressure air can really force the low pressure air out more quickly. Okay, so of course, if I'm going too fast through any of this, go back and listen to me one more time. But the final question was a comparison chart between El Nino and La Nina climate patterns. And really, here's the only way to be right on these. So for El Nino, which was not a suspect in the drought, we have reversed trade winds. For La Nina, they're normal. So because the trade winds reverse during El Nino, it blows water from west to east, which is not normal, and you have warm water by California. La Nina is like normal on steroids, so you have unusually cold water by California for La Nina. Now, this part, I think, is, if you think it through, is pretty easy. Warm air rises. Because it rises higher, the pressure during El Nino is lower. Because the pressure is lower, the jet stream says, come on through. I don't have the force to move you away. And because the jet stream, the superhighway for storms, comes through, it's above average precipitation. Now let's go over to La Nina. Colder water than normal means sinking air, sinking cold air above it, high pressure. Does this high pressure have the strength, the force to move the jet stream north of California? The answer to that is yes. And when the jet stream is stuck somewhere else and not coming through California, you get below average precipitation. Now, another way to understand this, check this out with me, right? This is El Nino. Either died down trade winds, or we actually can show a reversal, warmer than normal, lots of precipitation. Look at that. Really strong trade winds. That's La Nina. That's our suspect. And we can see that you get colder water, colder air, higher pressure over there. Okay, so you'll be retaking your quiz and task soon.